all 10 parts of gravitation. We have started this series for the preparation of CET, NEET and JEE. With your all request, today we are going to know more about semiconductor, right? So let us start with the semiconductor part 1. Now on the screen there is one waveform, and that waveform is nothing but sinusoidal waveform. This waveform is nothing but sinusoidal waveform. Sir, what this waveform belongs to, or what this half cycles belongs to? So for your kind information, whenever there is one cycle which starts from 0, 180 degree and 360 degree, this complete one cycle has been divided into two half cycles, that is positive and negative, and that became one complete cycle, right?
Yes.
And that is what is about frequency. What is frequency? What is definition of frequency?
Number of
cycles per second. Or many of the time we have heard number of oscillations
per second.
per second, right? So this is what about frequency. So if here in 1 second we have these many cycles, so it means this half and this half is one cycle, and this half is second cycle. It means this frequency is of 2 hertz. This frequency is of 2 hertz. What all parameters this frequency has, that we need to understand. The peak point is called as amplitude, right?
Yes.
Now peak to peak distance, or many of the time it says crest to crest distance, is called as wavelength. Peak to peak, successive peak to peak distance, right? Once we are calling peak to peak, it can be first peak or third peak even, but it is not like that. Successive peak to peak. Successive ka arth number 1, number 2. If you are considering number 2, then number 3. Immediate after, whatever number will come, that successive peak. And the first peak, the distance between that two peak or crest is called as wavelength, and that is denoted by lambda. And there is a relation between frequency and lambda. Is frequency is inversely proportional to lambda. Frequency is inversely proportional to lambda, right? So now this is again called as AC signal, and that is bidirectional. AC is alternating current, DC is direct current. AC is bidirectional and DC is unidirectional. Now, our concern looking at the semiconductor is, whenever P and N junction comes together, that forms diode. Pay attention here. I have drawn one symbol, and that symbol is nothing but diode. It has positive and negative terminal. What it contains? It contains P-type and N-type material. When positive and negative type of terminals or charges are coming together, which will certainly exchange each other, or technically we can call it as electrons will recombine with holes. It means here whatever may be the negative charges and here whatever may be the positive charges are, on this side of positive, all electrons will go and recombine, and whatsoever may be the original position of electrons, that became vacant, and that vacant space is nothing but holes or positive charge. It means here is one specific wall which is formed, and that wall is called as depletion layer. What this wall is called as?
Depletion layer.
Depletion. Now, sir, it is very good that without doing anything, electrons are recombining with positive charges, and that creates some potential right over there.
Yes.
We have already studied in 9th and 10th standard, whenever charges are exchanging, it means they are creating potential. Right? So sir, here we are getting potential. So that is very nice. No. That is a barrier. That is a barrier potential for remaining electrons and positive charges. Right? So we have to break this immediately so that all electrons will move toward positive and they will recombine, and then conduction will take place. And for that we need extra battery or additional source which will break the barrier potential or depletion layer. Right? So how it will break? Is there any hammer to break that? No. What will it do? It has negative on negative side, positive on positive side. It means this is in forward bias condition. This is in forward bias condition. So all positive will gather over here, all negative will gather over here. Now, looking at the properties of charges, two similar charges cannot attract, they will repel. So as here we have negative charges on both the sides, this electrons will certainly move towards the positive charges. Right? For moving that, it has to break this depletion layer. So certainly it will break the depletion layer, and all electrons will go towards positive side, and thus conduction will take place. Right? Now, this is what about the PN junction, right? And symbolically, I hope you people understood how PN junction works. Sir, you said it is in forward bias. So whether there is something called reverse bias? Yes. So in that case, this source direction has to change. It means where there is positive, there must be negative, and where there is negative, there must be positive. So when positive with positive and negative with negative is connected, that is called as forward bias, and then positive with negative, negative with positive is connected, then it is called as reverse bias. Right?
Yes.
So those who are listening to me, those who have to face the board examination, for them, this is what is important to know about forward and reverse bias. Now, talking about their characteristics that we will see later. First, coming to the symbol and the representation of AC signal to the diode. So this is what called as diode, right? It is in forward bias. If diode is connected in forward bias, it will conduct only for positive half cycle. It will not conduct for negative half cycle. Therefore, what happened? Whatever positive signal we have given, we got the output. Right?
Yes.
Now, for negative half cycle, what will happen? No. Keep this in mind. Many of the time, even engineering students sometimes say this is used to convert AC to DC. It is not. Diode is used to convert AC to DC. It is not. It only conducts for the positive half cycles. That is the only truth. Based on that, we can make it as a half wave rectifier, full wave rectifier, or some other rectifiers. Right? In half wave rectifier, it will conduct at for only one half cycle. In full wave rectifier, it will conduct for both the half cycles. Now, question arises, sir, if the fundamentally diode works for only one cycle, then for full wave rectifier, how it works for both the cycles? That question remains in our mind. So I will answer that question, but first understand the basic fundamentals how diode or PN junction works. So in the PN junction, it works for positive half cycle. It does not work for negative half cycle. Why? Because for negative half cycle diode became in reverse bias. It means negative terminal of source will be connected to the positive terminal of this PN junction, and positive terminal of the source will be connected to the negative terminal of the PN junction. Because of which they both will conduct on their own side, or they will attract the charges, but they will not break the potential barrier, and therefore conduction will not take place in reverse bias, and therefore it does not conduct for negative oxide. Now, further we need to understand something called as transformer. Sir, in between PN junction, why we are talking about transformer? Because after understanding concept of diode or PN junction and transformer, we have to recombine them, and we have to make one new circuit called as rectifier, and therefore we are understanding basic components of rectifier, right? So the first component which we have discussed is diode. Second component is transformer. For what reason it is used? It is used to increase or decrease the voltage. Pay attention. Before answering anything behind me, first try to listen. When I ask, just give your answers. Now, what is transformer? It is just used to change the voltage level. Again, many of the students have misconceptions that transformer always converts AC to DC. No. Again, it is also not converting AC to DC. It is just increasing or decreasing the voltage level, right, based on the mutual inductance present in the coil. It has two types, step up and step down. Step up is to increase the voltage, and step down is to decrease the voltage, right? Again, it has primary winding where we are giving input, the primary winding where we are giving input, secondary winding from where we are getting output. Okay. So after understanding basic component of rectifier, we need to understand what is rectifier, right? What rectifier does is a device which converts an alternating current into direct current. Now it is converting alternating current into direct current. Sir, you said for diode it is not converting AC to DC. You said for transformer it is not converting AC to DC. But you are saying by adding that 2, it will convert AC to DC. How? That question remains in our mind. Again I am telling, these two components are not converting AC to DC. Because of transformer it just decreases the voltage, and because of diode it just convert AC, complete AC, pure AC to pulsating DC. To pulsating DC. It means it is converting AC to DC but pulsating DC. As it has pulses. आपने देखा डायोड के एंड में वापस वो पॉजिटिव हाफ साइकिल दिख रहा था. If it is converting AC to DC, it must give you a straight line of direct current, but it is not, right? So we will see that. Again, rectifier has few types. Type number 1, half wave rectifier, and type number 2, full wave rectifier. Full wave rectifier again has bridge wave rectifier or center tap rectifier. But looking at your syllabus, I don't think that is important. But still, if in any case anyone has doubt in that, so we will discuss. Okay. So rectifier was discovered by Ferdinand Braun in 1874. He is the one who has developed the rectifier. So this is the basic diagram of half wave rectifier. First we have to connect transformer, second is diode, and it has AC input and DC output we are getting on one side. So we will see how it works. अब मेरा diagram is completely stretched, right? So how you should draw the diagram, or what must be the basic diagram? So see here, a transformer must be there. How you will draw in exam, or how you will do it in your practice. So this is what is expected, right? And this is ACS. Fine. This is the current diagram. Here it is in the stretched form, so symbols are scattered here and there, but no issues I have drawn over here. The above figure shows the circuit where AC is given through the step down transformer, and this AC is applied in series with the diode and load resistance. Right? Now, how it works, that we need to understand. Working for positive half cycle. When we are giving positive half cycle, A is positive with respect to B. We'll see where A and where B is. So from here we are giving this input, right? Yes. It has positive, negative half cycles in AC. Now initially it will conduct for positive half cycle. It means here we have positive half cycle and here we have negative half cycle. These are the two terminals of the transformer. So what we have mentioned here, A is positive with respect to B, diode D is in forward bias and it conducts. Current I flows through the RL. Here current I is flowing through the RL, hence we get output voltage across RL. So here we will get output for positive half cycle, right? Yes. In first step we have only discussed about positive half cycle. Now what happened to negative half cycle, that we have to see. Negative half cycle. Right. So for negative half cycle, again the input is this, right? Positive, negative, right? This is AC. Here now we have a negative half cycle and here we have positive half cycle. But A is negative with respect to B. A is negative. Diode is in reverse bias. So there is no current. There is no current flowing through RL, and therefore then we do not get output. We do not get any output. And that is why when diode is in forward bias, it only converts for positive half cycle. It will not conduct for negative half cycle. It only conduct at positive half cycle. So yes, this is what the output waveform. This is what happens exactly at the end of the diode. It means this input which we have given to transformer, and this is the output which we are getting at the end of load resistance after the diode. So what it does, it conducts for positive, it does not conduct for negative. It conducts for positive, it does not conduct for negative. And therefore D is on at positive, D is off at negative, D is on at positive, D is off at negative. And this is the waveform, right? And why it is called as half wave rectifier, it is very clear, because it is conducting only half cycle, one half cycle, and therefore it is called as half wave rectifier. Now, sir, what it is, how we have got the straight line? Because if we will add filters next to rectifier we will get pure DC. We will get pure DC. It means whatever circuit we have seen just now of rectifier, next to that if we will connect filters, right, then we will get the pulsating DC signal is converted to the straight line. It means this is stage 1, this is stage 2, stage 3. If you will increase the number of stages in terms of filter, it will certainly rectify it and it will give you the final DC signal, a straight constant line. So, sir, why that what that filter contains of? That filter carries capacitors and resistors as a basic component. Right? Based on charging and discharging of capacitor and based on resistance of offered by the resistor, it certainly suppresses the signal and converts it into the pure DC. Right? Now again, that filters part is not for your syllabus, so we are not discussing much on that. Now, what is the efficiency of half-wave rectifier? That is 40.6%. Sir, what is meant by efficiency? Efficiency is denoted by neta. Efficiency is denoted by neta, and that is nothing but output to input ratio. What? Output to input ratio. Sir, how it is? We have not understood what efficiency is. So very simple question for everyone. If you are attempting a paper of 100 marks, it means that is your input. You have attempted a paper of 100 marks, that is your input. But what if you are getting less than that? I am considering 95%. If you are getting 95%, that means that is the output. That is the output. And what will be the efficiency? 95%. What will be the efficiency? 95%. So output to input ratio is called as efficiency. Many of the time we can consider this efficiency for the electronic components, right? Generally we heard that this is not efficient, right? This is not cost efficient.
Yes.
Means whatever we are investing, it will not give us that much returns, right? So the output here in the rectifier, half-wave rectifier is 40.6%. So why it is so? Because whatever signal we are giving, that is not completely converting. And why so? Because every component has some tolerance. Every component has some tolerance. While understanding resistance and color code of resistance, right? B.B. Roy of Great Britain has very good wife with gold, silver and no color. In that we have 4 major columns: first digit, second digit, multiplier and tolerance, right? For gold, silver we have tolerance of 5%, 10%, 20%, right? So what that tolerance is? Whatever may be the manufacturing of resistance, no component is ideal. So there must be some leakage in every component. There must be some lagging in every component, and because of that, whatever electronic components we have considered, transformer, diode and resistance, everywhere some voltage will drop because of their internal resistance, and therefore the efficiency rate decreases to 40.6%. And the ripple factor is 1.21. Just keep this in mind. Ripple factor is 1.21. Now what is ripple factor? Right? The waveform, how that waveform reproduces, it has its parameter called as ripple factor, and that is 1.21. Right? These all things which I have mentioned here, this is just for your additional benefit looking at the half-wave rectifier. Otherwise, these parts are not much mandatory as far as your CET, NEET and JEE is concerned. but still those who are willing to go into engineering, for them these points are important. Now it's time to understand full wave rectifier. Now again we have transformer and two diodes, transformer and two diodes connected with RL, right? Again in the diagram the symbol of diode is not perfectly drawn, it must be like this, okay? Shubham, pay attention. And AC input must be like this. So now there are three terminals A, B and C. Initially in the half wave rectifier we were having only two terminals, now here we have three terminals. Diode D1 and D2. Now we have to see the working of it. The figure shows the circuit where AC is given through the step down transformer. So now this AC is applied to two diodes D1 and D2. Diode 1 utilizes a AC voltage appearing across the upper half, right? Yes. Of secondary winding. D2 utilizes CA means C2A and CB is C2B. D2 utilizes the lower half of CB of secondary winding. मतलब ट्रांसफार्मर का जो दो पार्ट्स किए हैं हमने, इसी को दूसरा नाम है सेंटर टैप. ये सेंटर में कनेक्टेड है, ट्रांसफार्मर का सेंटर पर कनेक्टेड है, so that is again called as center tap. So we'll see the working. For positive half cycle, A is positive with respect to C. For half wave rectifier we have written A is positive with respect to B, but here we have one more terminal called as C. So we are comparing A to C. So A is in the positive with respect to C and diode D1 is in forward bias, D2 is in reverse bias. D1 conduct, D2 does not. D1 conduct, D2 does not. Why? Because as we have seen that half of the portion is given to the one diode and half of the portion is given to the second diode. So positive half cycle is given to the D1 and negative half cycle is given to the D2 for first step. So conventional current flows through D1 to RL. It means like this. Current will flow like this. So now that positive half cycle will not go to the next diode, right? Now for negative half cycle, what happens to the negative half cycle? Now what they have mentioned, A is negative with respect to C, A is negative with respect to C. So now D1 is in reverse bias and and D2 is in forward bias. So D1 do not conduct but D2 will conduct. Now for negative half cycle, upper diode is in negative half cycle and the lower diode is in the positive half cycle. So initially first will conduct, second will not. Second time first will not conduct, second will conduct. It means we are getting output for both the cycles simultaneously. As we get output in both the half cycles, so it is called as full wave rectifier. Here the diagram is missing, so I'll just draw the diagram for you. It is like this, right? And now output is D1 is on, D2 is also on, D1 is on, D2 is also on. So here where is D1 on? The next is D2 on. D1 means it works for both positive as well as negative outcome. And again, as you can see, efficiency is completely doubled, right? Previously something about 40.6 or 46.0, whatever it is. Now it is doubled to 81.2, right? Note, this rectifier is known as center tap follower rectifier also. Already I have mentioned that. So in market, if we have to take rectifier, so in market this sort of rectifiers are available, right? So what these terminals are: terminal 1, terminal 2, terminal 3, right? One side it is input, middle one is ground, and last one is output. Again this varies with the manufacturers, right? So manufacturers to manufacturer this may vary, but one terminal must be for input, one is for output, and one must be for ground. So while taking input, so we will give input to input terminal and ground, and while taking output we will take output from one terminal with respect to ground. Again in market there are some series available: 7805, 7809, 7812, 7905, 7909, 7912. These are few series available. Sir, now what this stands for? So 78 series stands for positive of cycle, positive output, and 79 series is for negative output. It means if I am using IC 7805 integrated circuit, IC, this is called as IC. So if I take IC of 7805, it means it will give us positive 5 volt. If we are using 7809, it will give us positive 9 volt. It means it is restricted to that much of amplitude. Positive 12 volt, this is for negative 5 volt, this is for negative 9 volt, this is for negative 12 volt, right? Again, this is for your additional benefit if you wish to make your own mobile charger, right? That starts from transformer, rectifier, right? So if you wish to make your own mobile charger, you can bring that component and we can certainly make our own mobile charger. If half wave rectification is the input frequency 50 Hz, what is the output frequency? What is the output frequency of full wave rectifier for the same? What is the question? In half wave rectification, if input is of 50 Hz, so what must be the output frequency? Right? लॉजिक क्या कह रहा है तुम्हारा? अगर 50 हर्ट्ज का हाफ वेव को दिया और 50 हर्ट्ज का फुल वेव को दिया, तो आउटपुट फ्रीक्वेंसी क्या होना चाहिए?
हाफ होना चाहिए, 50 दे दे दो, क्योंकि वो एक कंडक्ट करेगा, एक ऑफ होगा.
We'll see. Since the output voltage obtained in the half wave rectification is once in one cycle of output voltage, hence the output ripple frequency after half cycle rectification is 50 Hz only, and in full wave rectification we get the output voltage twice the same direction, twice the same direction for one cycle of input voltage, hence the output ripple frequency after full wave rectification, right?
Yes.
So waveforms कितने मुझे मिल रहे हैं उसके based we can consider frequency. Initially we have seen the definition of frequency, number of cycles per second. So for half wave rectifier, whatever input we are giving, that much output we are getting, because whatsoever cycles we have passed, that much time it is taking to cover a cycle.
Yes.
Right? And for full wave rectifier, the number of cycle gets doubled. Right? And therefore it will give you 100 Hz at the output, and half wave will give 50 Hz. Okay. So let me check whether we can face any question based on this. So fine, we are stopping with the part 1 of semiconductor. We will again join very quickly for part 2 of the semiconductor, in which we are going to conduct few questions based on CET, right, which was conducted or which were asked in the previous examination even.
Okay.
So if you have any doubt, difficulty so far, let me know. We will discuss that out and we'll move ahead. I am waiting for your comments below this video after your revision. Thank you everyone.